Hello, students. Today we're going to go over a couple of questions from WebAssign number 6, which was about chapters 2.6 and 3.1. The first one is about using Desmos to get an answer to a specific point coordinate. In this question that was asked, I'll read it out loud and then we'll think about it together, okay? It says, you are given the formula for a function of x and the x value of the minimum. You are to find the corresponding minimum function value by plugging into the formula. So basically what's happening is we're giving you a formula. We're telling you what x is. You can go and find it either with a calculator or with Desmos, but the quickest and easiest way to get this done is to get it through Desmos. So I'm going to take this formula that you see right here. It's e to the 2x minus 4 e to the x. I'm going to put it right into Desmos. And in Desmos, I'll put in y equals e to the 2x minus e to the 4 e to the x. Wait, minus 4e to the x. That's what it is, minus 4e to the power of x. Okay, now the easiest way to do this, and it does tell you that the minimum, if you look, it says the minimum is at 0.69. It looks like the minimum, look, there it is right there. And you can see the y value, of course, is -4 for that question. So what we would do for that is we type in -4. If you type in -4, it'll get it. If you type in 4.00, it'll also get it. But it's saying to put it in 2 decimal places, which means you got to make sure you put 0, 0. If ever that happens on an exam, it marks it wrong, just let me know and I can award credit back. It's not a problem. Okay. We have 4 questions in total to go over. That was the first one. Again, if you have a question, please don't be afraid to send it in the chat or to unmute and ask a question, okay? For this question, we're asking you to find all maxima and minima of the function, and it's telling you on a horizontal span from -3 to 3. What that means is there may be other maxima and minima beyond those reaches of from -3 to 3, but we're going to not think about those. We're going to just look at the maximum within that particular range. It's a cubic function. It's x cubed minus 12x plus 8. So what I'll do is I'll get rid of this one and I'll type in y equals x cubed. And then what was it? Minus 12x plus 8. Okay, so there's your function. I could zoom out a little bit. Remember, it's only about between 1 and 3, so between -3 and 3. So maybe what I'll do is I'll use the wrench and I'll tell Desmos to only show me the graph from -3 up to 3. And now it's really pretty clear to me where the max and min are. I could just click in the area and then click it one more time. There's your max. It's at x equals -2 and y equals 24. And there's your min. So we will put those values in -2, 24, and 2, -8 right here. Notice that they're asking you to find the maxima and minima of the function. When they say of the function, what they're saying is find f at the max, find f at the min. In other words, give me the y value, not the x value. Okay, so when it comes to this, one thing I tell you to do is make sure that you're conscious of the span and use the wrench. The other thing I'd tell you is make sure you remember the idea of the terminology of the minima of the function means is the actual y value. Okay. Carrying on with more questions here. This question came, the question reads, a rope is stretched from the top of a 4-foot-high wall, which we use to determine the vertical axis. The end of the rope is attached to the ground at a point 16 horizontal feet away at a point on the positive horizontal x-axis. What is the slope representing? What was the slope of the line representing the rope? Okay, so here's the way I'm thinking of this. I'm thinking about some geometry. I'm going to make a drawing. I'm going to hope that you guys can follow my idea of a drawing. Here we're talking about the XY plane, and we're talking about 4 foot tall at the top of its 4 foot tall. It goes out 16 feet more. So let's say this is 4 right here. And then this is 16 over here. And now if I give my line, it goes from 4 to 16 like so. Now there are a couple ways you could think of this line. Notice I'm pushing it to the right because it's telling you it's on the the positive side of the horizontal axis. So it's not going to the left, it's going to the right. That does tell you that it is ultimately going down, you know. And I noticed that I did deliberately exaggerate how far away 16 was in compared to how high up 4 is, because we should be farther away this way than we are this way if it's a height of 4 and it's going out 16. So because of that, I have a rise of 4 and I have a run of 16. But the thing is, it's actually not rising, it's actually falling. So it's more like a fall, which means it's like a negative 4. So I'm going to consider this to be like negative 4 divided by 16. And when you reduce that, of course, you get negative 1/16, like so. Okay, now I hope that that helps and makes sense. That's how you would answer this question. Let's take a look at the next question. Welcome back, students. This question is about the California State Highway. It says California State Highway 108 crosses the Sierra Nevada mountain range at Sonora Pass, the second highest highway pass in the Sierra Range. The route features striking natural beauty as well as some very steep highway grades. Just west of the pass, one encounters a sign that says 28% grade next 2 miles. Of course, this means that the maximum grade over the next 2 miles is 28%. Nonetheless, this is an extraordinary steep state highway. Suppose that the highway is in fact a straight line with a slope of 0.28 and that the elevation at the beginning is 6,000 feet. If you are moving up the mountain, what would be the elevation after 2 horizontal miles? Well, there's a couple of things here to consider. First of all, 1 mile is 5,208 feet. So if we're going to have a grade of 0.28 and we're going to start at 6,000 feet, we have to consider the horizontal distance to be in terms of feet as well, instead of in terms of miles. That's not hard to do because if 1 mile is 5,280 feet, all I have to do is simply multiply that number by 2 to figure out what it would be in terms of 2 miles. So 2 times 5,280 is going to be 10,560. So that is the actual distance after the 2 horizontal miles. I'm going to put a little note here. That's 2 horizontal miles. Okay. Now that be the case, the next thing I'm going to do is write a little bit of an image. If I draw an image, starting with the idea of this uphill highway, right? And I consider that the slope of that is actually supposed to be 0.28. Let me jot that down. And further, I know that I'm actually going 2 horizontal miles. And when they say horizontal miles, they mean horizontal straightforward, not along the path, but as if you were driving into the dirt. So if it's 2 miles or 10,560 feet, I would say that in my little right triangle here, that what's actually happening is this length right here is going to be 2 miles or 10,560 feet, like so. And now the other thing that we know of is we have a grade of 0.28. Now, they're telling you that at the elevation beginning is at 6,000 feet. What would be the elevation after 200 miles? So we're also telling you that the elevation is at 6,000 feet right here. I'm going to draw it with an arrow to make it clear. All right. So in other words, right here, we're actually already 6,000 feet up into the air. We like to know exactly what height is this right here. And we can do that if we first figure out very carefully this height right here. Now, that's not hard to do because we do actually have the run and we do actually have the slope. And you might recall during our lesson that there were a lot of really great little formulas. And one of them did relate the slope and the rise and the run in such a way that it was solved for the rise. See, the story goes, if the slope is rise over run, like this, and please excuse my chicken scratch handwriting, I'm trying here. If you multiply both sides by run, can you see that rise is going to be m times run? So that's telling you to figure out 0.28 times 10 to the 560. So with our calculator, let's do that. That'll take just a minute. That's going to be 0.28. No. 0.28 times 10 to the 560. And I'm getting 2956.8. 2956.8. And that again equals 2956.8. So using that formula, I have come to the realization that right here, I have a measurement of 2956.8. Now remember, it's 6,000 above. So that number plus 6,000, that's what you're gonna get when you look right here. Here it is. That is the answer to this one. So let's just review. One thing that you have to know about is when they talk about grade, they're talking about a steepness in a road that you're driving on. The horizontal distance is actually the perfectly flat distance as if you were driving into the dirt, regardless of the road going up a hill. So that's why 10,560 feet is the run. Also, there's another curveball in this question. It's 2 miles, but we're talking in terms of feet. And we do give you a hint. We tell you 1 mile is 5,280 feet. And you can use that to interpret the run in terms of feet instead of miles. Then if we use our formulas correctly, we can identify what the rise would have been, and also being conscious of the idea that it's up in the air already in the mountains at 6,000 feet elevation, that we can get the answer by adding those two numbers, 6,000 plus 2,958. So that's that one. And I do have one more I'd like to go through. Let's take a minute and get to that one. Okay, we have another question here. This one is an application question, and there is graphing involved in it. In this one, you'll see there are many variables, but we tell you flat out what some of the variables are going to be equal to, so you can just plug them in, kind of. Let's talk now about fish management. In fish management, it is important to know the relationship between the abundance of the spawners, also called the parent stock, and the abundance of the recruits. That is, those hatchlings surviving to maturity. According to the Ricker model, the number of recruits R, as a function of the number of spawners P, has the following form for some positive constants A and B, and we have a format there. The model describes a phenomenon observed in some fisheries. A large spawning group can actually lead to a small group of recruits. In a study of the sockeye salmon, it was determined that A equals 4 and B equals 0.7. Here we measure P and R in thousands of salmon. Make a graph of R against P for the sockeye salmon. Assume there are at most 3,000 spawners, so P is at most 3. Now remember, they told you P and R are in terms of thousands. So to express 3,000, we would just want to let P equal just 3. We're going to take this formula and rewrite it specifically in the places of A and B. I'm going to purposely change those numbers out right there into the numbers that they're giving me. So let me start by doing that. We'll say R equals A, which is 4, P E to the power of negative BP, and B we're giving as 0.07, so that would be negative 0.07. I'm sorry, 0.7 P. So you'll notice in this case we have two variables. We have R and P. P happens to appear twice. This is comparable to the formula in terms of X and Y that would look like this. Y equals 4xe to the power of negative 0.7x. The reason I'm writing it that way is because that's something I can get a graph of quick and easy using Desmos. And now what I'd like to do is take that very graph you're looking at and type it into Desmos and see what it looks like. I'm also going to try really hard to get it to look like one of the graphs I see below. And if you look at the graphs below, you'll see that they are all kind of in the same realm when it comes to the axes. Let me get a good image of it so you can see what I'm talking about. Try to ignore my writing for a minute. All right, but you'll see that they all go up to 2.5. I'm looking right here. Let me just, I'm looking right here right now. You see, they all go up to 2.5. Right? Likewise, they all go out to 3. And if you go down, you'll see that too. So what I'm going to do is I'm going to try to get a picture of this graph of this function going on the x-axis from 0 to 3 and going on the y-axis from 0 to 2.5. So let's now go to Desmos. Remember that it's 4xe to the negative 0.7x. So we say y equals 4xe to the power of negative 0.7x. And there's my function. I also would like to see this function specifically from the x-axis of 0 to 3 and on the y-axis from 0 to 2.5. Now, doesn't it look like one of the answer choices? Look at it. Now it really, really emulates one of the answer choices. Let's go back and look at the answers. Some things that are important here, I'm going to click on it and notice that it does give me a maximum. It's an odd function. It's a strange function, but there is a maximum value, and there it is. It might help to consider that that actual number is really right around 1.4, 1.41 or something like that, and use that when you're trying to figure out which one it is. As you can see, this is the answer that they're looking for right here. And the others really do pale in comparison to that. Take a look at the others. So it's definitely none of those. It's got to be that one. So the trick to getting part A correct is just making sure that you're really on top of that idea of the axis, how it has to go from 0 to 3 and 0 to 2.5. Then after that, there's another question here. It says, find the maximum number of salmon recruits possible. That we can get right here. And you can see it's 21022. Remember that it's the actual y value that is the actual number of recruits. And that being the case, this is in terms of thousands. So I'm just going to really move the decimal point 3 spots. It's really 2102.2 salmons, and of course, there's no such thing as 0.2 salmons. So it's 2100 salmons. That's what we were looking for that question there. Okay. The next one says, if the number of recruits R is greater than the number of spawners P, then the difference R minus P of the recruits can be removed by fishing. The next season, there will once again be spawners surviving to renew the cycle. What value of P gives the maximum value of R minus P, the number of fish available for removal by fishing? Answer to 2 decimal places. So for this question, we do have a recruiting and we do have a recruiting and we do have a parents, right? What are the variables again? Spawners are P, R is recruits. So then the difference R minus P of the recruits can be removed by fishing. And next season there will once again be P spawners surviving to renew the cycle. What value of P gives the maximum value of R minus P, the number of fish available for removal by fishing? Well, R minus P is actually going to be very similar to what you have. See, you have right there P equals, right? So if that's P equals, then what we could do is R minus P. Remember, R is the X value. So if I put in there R equals, I'll make it actually X minus all of that stuff that you see there. Like so. And when you do that, we have a new function. Let's zoom out a little bit. You have a new function. As you can see, it crosses through in 2 places. Here's where it crosses. Let's see if that's our solution. Does that make sense? 0.80 thousand salmon. See if it says, question is actually asking, what value of P gives the maximum value of R minus P, the number of fish available? R minus P. Oh, R minus P. Well, if this is R, then R minus P is all of this minus P. P is X. Okay, I think I had it backwards, guys, and I'm sorry. It should have been more like this. Okay, yeah, that's what it was. See, they're trying to say R minus P. Remember, this is R, and P is the X in the story. So if this is R minus P looks like the same thing, but minus X. And when you graph it, look at what you get. The X value is 0.802. That's why 0.80 thousand is the answer, which 0.80 thousand really means 800, right? Let's look at the answer there. What is the answer? Oh, the good news is you didn't have to change it. You could just leave it. It says 1,000 there, so you can leave the 0.80 as your answer. Okay, so I hope that that makes sense. That was a little tricky. Part C, what they were doing is they were trying to confuse you with variables. Like, do you remember which one was X and which one was Y? In this situation, the way we set it up initially was we made it that R was Y and P was X. So to figure out the answer, we had to do that what we just have of minus X right after it. Okay. All right. So I hope that that was helpful. Some great explanations there. I'm going to come back if there are any more questions. I think there might be. I'll go and check in a minute. Let's see. But if there are any other questions, please go ahead and submit them into the chat and we'll take a look. Thanks a lot for your attention, friends. I appreciate it. Welcome back, students. Now we're going to talk a little bit about a function in Desmos using the square root function. It could be a little bit hard to identify where you'd find the actual square root sign in there. I'm going to show you that now. We're asking you for this question. Here's a function. Please find the minimum on a horizontal span from -5 to 5. So I'm going to go into Desmos again. Okay. And then in Desmos, I'm going to go ahead and take this function. It's y equals 9 times. And then I have to get a square root, and it's x squared plus 1. And then notice that this minus x is outside of the root. So make sure you're careful about that. But I want x squared plus 1 inside the root. So I could do that by getting the little keyboard down here on the corner. Open it up, and it gives you a square root option. Here it is. And then inside the square root, I'm going to put in that expression. It was x squared plus 1. Get in there. X squared plus 1. Then to come out of the square root, just like coming out of an exponent, you hit the right arrow and you get out. And now I got to do -1, right? Oh, minus x, my bad. It's minus x. Okay, so let's make that minus x. Now I can close the this keypad, and I don't see the function. Let me zoom out a whole bunch and see if I can find it. There it is. Okay. Now, if I'm trying to think about this function only on a range from, and they gave you -5 to 5, see that? So let's change the wrench and let's go ahead and figure out on the x-axis what happens if I make this -5 to 5. Okay, and as you can see, it doesn't look like it has a maximum there. Are they asking for a minimum? They're asking for a minimum. So let's click on it, and you'll see there's 2 dots. If you look real close, let's zoom in a little bit more with the plus. Zoom in a little more. See there's 2 dots? Kind of tricky. This dot, of course, is an intercept. The reason why that's included as a gray dot for reference is because it's the place where it crosses an axis. This one is included because it is a minimum. So in this case, the minimum is an x value of 0.1118, and then the y value 8944. As you can see right there. Okay. Chances are, if you were having trouble finding the answer to this one, you might have confused the intercept with the actual dot, because if you don't change the span from -5 to 5, you won't see that the minimum is actually so very close to the origin and to the y-axis. So anyway, that's how you get that one. And then there is another question. Let's go and take a look at that one as well. So for this one, we're saying the Americans with Disabilities Act requires, among other things, that wheelchair service ramps have a slope not exceeding 1/12. Suppose the front steps of a building are 4 feet high. You want to make a ramp conforming to ADA standards that reaches from the ground to the top of these steps. How far away is the building from the building is the base of the ramp? So this is very much like the last question we did about the grade of driving uphill with the 0.28, if you recall. Instead of 0.28 being your slope is 1/12. Here, we're saying you want to make a ramp conforming that reaches from the ground to the top. So since they're saying not exceeding 1/12, it can be less steep than 1/12 if you want, but we're going to go with 1/12 as the steepness or slope in this case. So let's make some drawings now, okay? Suppose the front of the steps of the building are 4 feet high. That means I'm going to start, let me get my annotate out. Here we go. That means we're going to start with something that is 4 feet up in the air. Okay. And then you want to make a ramp conforming so that from the ground to the top of the steps, how far away from the building does it have to be? So let's get creative and pretend it looks like this. Okay. And what we know for sure is that this measurement is 4. We also know for sure that the slope is 1/12. So we're trying to ask how far away from the building should it be, meaning, and I'll use a different color to show this, meaning what is this length then, is the question. Okay, so how can we get that? Well, the purple length I just drew is ultimately the run, right? And likewise, the measurement over here is the rise. So recall that the slope equals the rise over the run. And if you wanted to solve for run, you could multiply both sides by run and multiply both sides by rise, or you could put them in different positions. I would do it like this, actually. I would say two fractions are going to be equal. Okay, the first fraction is the slope, 1/12. The next one is the rise over the run. I know what the rise is. The rise is 4. The run is down here. I'll just call it x this time. And then if you go through the motions of solving this little inequality, I'm sorry, it's not an inequality, my bad. It's a proportion. Of solving this little proportion, I'm going to use my spray paint can to show you what I mean. So if you go like this, and then you go like this, right? You're going to get 4 times 12 equals 1x. And then if you simplify, I think you could see that it's 48. Okay, so that's the answer to your first question. Let's look at the second question now, guys. Okay, it says, and another way to give specifications on a ramp is to give allowable inches of rise per foot of run. In these terms, how many inches of rise does the ADA requirement allow for 1 foot of run? And the answer is 1 inch. And the reason why it's 1 inch is because this right here, this is conceptual, this is not mathematical. This number right here, 1/12, 1/12 of a foot certainly is 1 inch. And if you think about 48 inches and you think about 4 feet, you could think of it in terms of 4 feet divided by 48 inches. Some students will think of it in that way. Any way you look at it, though, it's supposed to be that 1/12 still connects to this concept, and 1/12 of a foot is 1 inch. It might be a little misleading that it is not really very clear there, but it is in inches, the answer they're looking for. Because the correct answer to this question ultimately is really like if it's one, then the other thing is 1/12. Well, what is 1/12 foot? The answer is 1 inch. And that's the trick to that one. Okay, so I hope that helps a little bit, my friends. We're going to stop there. And then again, if anyone has any questions or anything else to WebAssign, that's why I'm here. Please let me know. See another one here now. We could talk about this question. This is again a great candidate for a Desmos graph. This one is saying the rate of growth G in the weight of a fish is a function of the weight W of the fish. For a North Sea cod, the relationship is given by this formula, where W is measured in pounds and G is in pounds per year. The maximum size for a North Sea cod is about 40 pounds, so make a graph. Notice that since the maximum size for a North Sea cod is 40, so the x-axis on all of the examples here only go to 40. Notice they also happen to all rise up to 4, right? So what I'll do now is I'll go to Desmos and I'll go ahead and put this function in. I'm going to change the G into a Y. I'll change W into X. And then I'll change the X and Y axes using the wrench, specifically having the x-axis go from 0 to 40, and I'll make the y-axis go from 0 to 4. So let's put this formula in. It's 2.1 w to the 2/3 power. So it ought to look like this. Y equals 2.1 x to the 2/3 power.
Professor, we can't see your screen.
Oh, I'm glad you said something. Thank you. Hold on just a minute. I thought I had shared it. No, I didn't. Good one. Okay. Thank you for telling me. I appreciate it. Let's go back for a minute. The question we were looking at is here. And in this question, they're saying which graph is associated with this formula. Okay, so what I'm doing then is I'm changing g into y and changing w into x, and I'm going to have this function, it'll be minus 0.6x last. Okay, so we have a function. Take a look, friends, at this interesting little phenomenon that happens sometimes in graphing. I'll put a little star by it. Notice at the origin, we have a very sharp corner there that happens often when you're looking at fractional exponents. You get a weird, hard corner like that. So anyway, that's something that happened there. Interesting, just part of math. But the question that they're asking is, can you please take this and go from 0 to 40 on the x and go from 0 to 4 on the y? So all we have to do now is change the wrench. Oh, no, I put a star on the wrench. Hold on. I meant to do this. There we go. Okay, so select the wrench. Now on the x-axis, let's go from 0 to 40. And on the y-axis, let's go from 0 to 4. See how it keeps twisting and bending the line? Like you're never going to know what the line looks like unless you carefully command what the x and y axes labels are that way. So now we have a nice picture, and it really is pretty clear to me, what the answer is here. Let's look at the different options. Really looks like that first one, actually. That is really the one that pops out more than the others. Let's see. Or no, maybe not. The hill is to the left a little there. I think it's more like D. And if you could see, they're telling me I have the answer key. So you're looking at the answer key of the question. Of course, that is the answer. Okay, now the next thing says, find the greatest rate of growth amongst all cod weighing at least 7 pounds. Round your answer to the nearest decimal places. Now, they say at least 7 pounds. At least 7 pounds means anything that is to the right of the number 7. Now, in this situation, the number 7 happens to be, and I'm going to use my star again, 7 is right about here. So they didn't really have to tell you weighing at least 7 pounds. The maximum of the graph still follows the situation that it happens to be greater than 7 anyway. So that being said, now let's take a look at our graph once more and see if we can determine the maximum there. I'll just click on the blue line anywhere, and a gray dot is there. I'll click on the dot, and as you can see, 12.704, 3.811. Our answer is supposed to be 3.81. Okay. The next thing is saying find the greatest find the greatest rate of growth amongst all cod weighing at least 22 pounds. Now, at least 22 pounds. Where is 22 on here? 22. I'm going to change this into a table so I can get some values out here. 22, 20, 21, 22, 23, 24. Take a look at the dots that I put there. Those are the dots associated with the x values 20, 21, 22, 23, and 24. Very helpful information. And if you change this and you make it instead to just go up to, and what were they asking about? Up to 22 pounds. So if you go only up to 22 pounds, you'll notice everything beyond 22 pounds is going down. The question is saying at least 22 pounds. What is the greatest rate for at least 22 pounds? For at least 22 pounds, all of these candidates are all of these dots are all at least 20 pounds. The greatest one of them, again, and I'm going to use my star, is this one right here. This is the best one. This is the example in class we discussed of an endpoint being a max or a min. See, if we're talking about this function from 22 and on, then we're not talking about the left part that's blue. We're talking about the purple highlighted spray painted part that I highlighted there. We're only looking at that graph like as if it's just from that down. What is the highest point on that graph? It is the actual leftmost part. It's an end point. So sometimes an endpoint is an answer to a question when you're asking for a maximum. Notice the y value there is 3288. Look now at the answer to the question is 329. Okay, so sometimes, and let me get rid of my spray paint graffiti there. Sometimes what'll happen is you'll look at a graph and you'll try to determine what the max and min is, and it won't look like it'll have one because it doesn't have a bend. Like the way a parabola has a bend, it's just like a line. Sometimes the highest point is just the answer of what the max is. That's what happened here. It's a great example of an endpoint question, part C. Okay, there is another question I'm going to address. Let's go and get that. Okay, friends, now another student asked about the same question, but I think you know that everyone has different questions. So like, for example, right here, now they're asking you about what if it was 24 pounds? And actually these two questions go together very nicely. It's the same question, but modified from student to student. What if you change the number from 22 to 24? Well, we still have the graph. Let's look at it. What happened to 24? Look at the value for 24 right here. So at 24, the number is 3.072. And I think you can see it's the same case. That does represent the highest value in an endpoint situation. Okay, so we're going to select 3.072. Let me confirm that that is the correct answer. And it is, in fact, the correct answer. Remember, they wanted the 2 decimal points. And I hope that that helps you guys a little bit. That's your example of the endpoint. That being said, friends, I see that our time is just about up here. It looks like we got a lot of really great work done. Excuse me, I really commend you for your hard work. I can see that this is not a piece of cake. It's challenging, but it's the fact that you come here and that you try, that's where your learning is, and it's evident when I look at your test grades that this class is doing very well. Very impressed with everybody's test scores. So what I'm going to do now is I'm going to formally dismiss. It is 2:21. I'm still yours for 4 minutes, or if anyone wants to stick around and talk, I'm still here, and you're welcome to. But we are officially dismissing now. Thank you for coming today. And this will be posted on eCampus shortly. So if you want to go and look and review once more, you can do that. Thanks for your attention, friends, and have a beautiful day.